So, artificial intelligence is changing everything, right? But probably not in the ways we usually talk about. Let's forget the algorithms and the data for just a second. The real story, the engine driving this whole revolution, it's actually about economics. The fundamental rules for building powerful technology have been completely rewritten, and we're in a whole new game now.
And this one sentence, it just perfectly captures the new reality. For decades, the biggest bottleneck in tech was finding enough brilliant people, but that's not the main barrier anymore. It's money. In chemistry, the limiting reagent is the ingredient you run out of first, the thing that stops the reaction. Well, in AI, that's now cold, hard capital.
So, what does that shift actually mean? Well, it means the old playbook for building software, where you hire more people, but eventually you get diminishing returns, that's been completely shattered. We've gone from a world where the hardest problem was coordinating talented people to a world where it's all about how much capital you can deploy and how fast. And you gotta understand, these two sets of problems are like night and day. The old challenges were all about people, finding engineers, managing teams, dealing with communication overhead. The new constraints, they're industrial. We're talking GPUs, the physical space for massive data centers, and just absurd amounts of energy to power it all. It's a huge shift from managing teams to basically managing the supply chain for intelligence itself. And this entire dramatic change, it really all boils down to one core principle that's come out of AI research over the years. It's called the bitter lesson. And it's called bitter because, well, for a lot of very smart researchers, it was a tough pill to swallow. It basically says raw power beats human cleverness. You see, for decades, AI researchers tried to build these really elegant, clever systems, basically trying to hard code human genius and knowledge into an algorithm. But the bitter lesson taught us that in the long run, simple, general methods that you can just pour massive amounts of computation into will always win. They just scale in a way that human-tuned systems never can. Think about it like this. AI isn't really getting smarter because of some eureka moment with a new algorithm. It's getting smarter because we're just throwing another 1,000 GPUs at the problem. More compute simply equals more intelligence. It's a simple and, honestly, a pretty brutal equation. And this lesson isn't some academic theory anymore. It is the playbook in this insane, high-stakes arms race between the world's biggest tech companies. They all get it now. Winning isn't about having the smartest engineers anymore. It's about who can command the most compute. And that takes billions and billions of dollars. And if you look closely, every single one of the big players is making a massive bet on this, each in their own way. OpenAI is raising money like it's a small country because they know capital buys the GPUs that build the frontier models. Google is leveraging its insane resources to build out an internal AI infrastructure that looks more like a national lab than a tech company. Meta has become one of the world's biggest buyers of GPUs, turning all that capital into powerful open source models. And then you have Amazon, just selling the picks and shovels to everyone else, renting out its massive cloud to the entire industry. So, all of this activity, all this spending, it all boils down to a brand new formula, a new equation for what it even means to be ambitious in the world of technology today. And here it is, the new formula for success. Talent times compute times capital equals capability. And that times is the most important word in there. It's multiplication. Which means if any one of those three ingredients is zero, your entire result is zero. You could have the smartest people on the planet, but with no compute and no capital, you're a nobody in this new race. You are completely irrelevant. And the results of this formula, they are absolutely mind-blowing. We're starting to see small teams take on problems that used to be the domain of entire nations. We're talking about things like designing new drugs in seconds, predicting the structure of pretty much every known protein, or even building AI that can run its own scientific research. It wasn't that we weren't smart enough to solve these things before. It's that we literally didn't have the horsepower. It was computationally impossible. But now it's just becoming an economic problem. Okay, so this new reality has some pretty huge consequences for the cost of just doing business, for innovating. It means we are walking into a future that is way, way more expensive, but also way more ambitious. I mean, think back just a few years ago. A software company that raised $100 million, that was a huge deal. That was considered massively ambitious, set to hire hundreds of people and build a huge organization. Today, $100 million barely gets you in the door. It might spin up a tiny fraction of a computing cluster for a little while. The cost to train just one cutting-edge AI model is now getting close to $5 billion. The scale has just shifted by orders of magnitude. It's on another planet. And this is totally rewiring how money flows in the tech world. Investors are cutting these enormous checks for very young companies. Burn rates are exploding, not because people are being reckless, but because GPUs have become the new factories, and they are incredibly expensive to run. And the growth you get is nonlinear. You might add 20% more compute and get a 60% better model. That's an incredible return on investment. Now, it is super easy to get lost in all the hype, right? The debates about AGI, whether these things are conscious, but honestly, that's kind of missing the forest for the trees. The true underlying breakthrough here is something much more practical and way more powerful. This is it. This is the key insight. For the first time, really, we've found a way to take a whole class of incredibly complex, difficult technical challenges, problems that used to be limited by human ingenuity, and just turn them into economic problems. Problems you can solve by simply applying enough capital and compute. And this creates this incredibly powerful, self-reinforcing loop. Think of it like a flywheel that's just starting to spin up. Capital gets transformed into compute. That compute creates brand new capability. And that capability generates these accelerating returns, which, guess what, attracts even more capital. That loop, that is going to be the engine of progress for the next couple of decades. The center of gravity has permanently shifted. Building the future with AI at the highest levels is no longer an engineering challenge. It is an economic one. And the winners will be the ones who can deploy capital at a truly global scale. And that leaves us with one final crucial question. If ambition requires capital, and capital buys compute, and compute creates capability, what does this mean for nations, for global power? When intelligence itself becomes an industrial product that you can essentially just buy, we're not just talking about the future of technology anymore. We might be looking at the new architecture of global competition itself.